This is 7.3, the normal distribution, more in depth than what we had before. And if you'll recall the basics, which we had before, normal distribution, frequency distribution, that occurs when there's a large number of values. It's a bell-shaped curve. Right here you have the mean. The mean and the median are the same on a normal curve, and all you need is the mean and the standard deviation in order to find out what's under here. This is 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. And a standard deviation is a number. Okay. The average healing time of a certain type of incision is 240 hours with a standard deviation of 20 hours. Sketch a normal curve that represents the frequency of healing times. Okay, so we have a average healing time, that's our mean right there, of 240 hours. So that's where you start, right in the middle with 240 hours. The standard deviation is 20 hours. So you would add 20 to this side to get 260. That's a standard deviation above the mean. A standard deviation below the mean would be minus 20, which would give you 220. Then you're going to do the same thing for 2 standard deviations. Add another 20 here, which will give you 280. Or right here, 2 times 20 is 40 to give you the 280. Subtract it off here, which will give you the 200. Okay. And then for 3 standard deviations, you're doing it yet again. Taking off 60 from here, which is 180. Or adding 60, which is 300. You can do it 20 at a time or 20 at a time that way. But that is how you sketch a normal curve with the values that are on this, are given in the problem. So here's your first problem that you'll be turning in. The weight of a box of cereal averages 565 grams with a standard deviation of 5 grams. Sketch a normal curve that represents the frequency of box weights. So you will need to do that on the Google Doc that's attached in your in the assignment. Also told you about the empirical rule before, 68, 95.5, 99.7 rule. About 68.3% of the data, or 2 is sometimes given out, is between 1 standard deviation and the next. So when we were putting this in, 1 standard deviation between 220 and 260 would give us 68.3% of the data. 95.5% of the data is within 2 standard deviations. So that's saying go down here to 200 to 280. That is 95.5% of the data. 3 standard deviations all the way from 180 to 300. That is 99.7% of the data. So that is called the empirical rule, and it is used right here. So I brought the normal curve back that I was going back and forth on. Refer to example 1. That's right here. Suppose a hospital has treated 2,000 patients in the past 5 years having this type of incision. Estimate how many patients healed in each of the following intervals. 220 to 260. So you are looking from here to here. That is mean healing time of 240 and 1 standard deviation here to here. 1 standard deviation is that 68.3%. So what you are doing is you are going to take 68.3% of that 2,000. So 0.683 times 2,000. So I have decimals up here? I don't. Alright. Get a calculator here. 0.683 times 2,000 means I'm going to have 1,366. There will be 1,366 patients between those 2 hours, 220 to 260. When you drop it down one more standard deviation in either direction, that's 2 standard deviations, which gives you that 95.5%. You are going to multiply here 0.955 times 2,000. That's going to give you 1910, so 1,910 patients out of the 2,000, so it's very close to 2,000, were healed up between 200 and 280 hours. Now once you go one more standard deviation, all the way to 3 standard deviations, that's when you get that 99.7, so almost 100% of the people fall in those 3 standard deviations. 0.997 times 2,000 means all but 6 were healed up in those hours. 1994 out of the 2,000 patients. So only 6 were not healed at that point. Okay, so here is where you are going to do a problem. Oh, no. This is one going from another example. Suppose that 6,000 boxes are taken from the assembly line and checked. How many boxes fall within each of the following intervals? Okay, well, I've got 565 grams and a standard deviation of 5 grams. So that means if I were doing a normal distribution, well, it should be right in the middle. 565, right in the middle. And on either side, for one standard deviation, I would have 5 behind and 5 above. So 560 to 570 is one standard deviation, which is 68.3%. Going a second standard deviation is minus 5, 555, and 575. That's what we got right here. That's 2 standard deviations, which is 95.5%. Okay. And taking off one more time, 550 and up to 580. Okay, up to 580. That's 3 standard deviations, which is, took my 9 off, 99.7. So once again, you're going to multiply these out. 0.683 times 2,000. 0.955 times 2,000. Whoops, 6,000 in this case, not 2. Alright, I don't know why that works. Okay, let's have to use the mouse before I can get back to the pen here. 955 times 6,000, and then 0.997 times 6,000. So let's move this over a little bit so you can see it. 0.683. Whoops, I'm missing my point. 0.683 times 6,000. 4,098. So within one standard deviation, You covered 4,098 boxes. 2 standard deviations, 0.955 times 6,000. And we covered 5,730. Okay. For the last one, 0.997 times 6,000. 5982. So that covers all but 18 boxes. When you go out to 550 to 580, you've covered all but 18 boxes of the stuff that is being produced. So let's stop the video here and I'll go one more. This is your second problem to turn in. Suppose 260 values in a set of data are normally distributed. How many values are within 1 standard deviation of the mean? How many values are within 2 standard deviations of the mean? And how many values fall in the interval between the mean and 1 standard deviation above the mean? So that's a little bit of one that you've got to think about for a second, but it shouldn't be too hard. See you in the next video.